Hello class, this is Mr. Hart, and in this podcast we want to look at how we can convert between the position time graphs and the velocity time graphs that we looked at last time. So sometimes you're given the position time graph, but you really need to get the velocity time graph and vice versa. So we want to be able to move between these two graph types, the position time graph and the velocity time graph. Okay? So there's a general principle for switching between these graphs, and let's take a look at that. So when we're trying to do this transition between the position time and the velocity time, we're converting between these two graphs. Here's the rule. If you're moving from a position graph to a velocity graph, then you're going to take the slope at each part of the position graph. Okay? If you are moving from a velocity graph to a position graph, then you're going to take the area underneath each of the velocity graphs. So I know this doesn't make a whole lot of sense right now, but let's look at some examples and I think you'll be able to figure out how this works. Okay. So let's say we're trying to convert this position time graph to a velocity time graph. Okay. What you're going to do is, like it said, we're going to take the slope at every single point on this graph, or at each individual part of this graph. Okay. So looking at the motion of the object, okay, it moves forward until it reaches 5 meters. It sits still for about 5 seconds, and then it starts moving backwards. Okay, so if we're trying to make the velocity time graph over here, okay, then we need each velocity or each slope of this graph. Okay, there's kind of 3 parts you can think of. This forward line right here, the sitting still, and then the moving backward. Okay, so this forward part, it moves forward 5 in 5 seconds. Okay, if you remember from your math class, the slope is the rise over the run. Okay. So when up 5 in 5 seconds, or in other words, the slope is 1 meter per second. Okay. So on our velocity graph over here, we're going to start at 1 meter per second. Okay. And let's see, that's for 5 seconds. Okay. So for those 5 seconds, they are at 1 meter per second. So that's the first part of our graph. Okay. Then for the next 5 seconds, they are sitting still. Okay, well, sitting still, that's a slope of 0 meters per second. And so from 5 to 10, and I realize I didn't provide enough room, but for 5 to 10, they're going to be at 0 meters per second. Okay. Then for this last slope, they go down 2 every time they go over 1, right? So it's -2 over 1. Okay, they went down 2 over 1, so that's a slope of -2 meters per second. And if I provided more room on this graph, the velocity would go down like this. Okay, so they start at 1 meters per second, they go to 0 meters per second, and then they go jump down to -2 meters per second. Okay, so that's the velocity time graph for this position time graph. Okay, so you're just finding the slope at each individual part and plotting it on the velocity chart. Okay, so go ahead and try this one by yourself. Go ahead and pause the video if you need to, but see if you can find what the velocity time graph would look like for this graph. Okay, so if you did the problem, you should have found that the slope at this part of the graph is 60 over 10, or 6 meters per second. All right, for this part of the graph, it's 0 meters per second. For this part of the graph, they go down to -40 in, it looks like 15 seconds. 15 to 40 is, or sorry, 25 seconds. 15 to 40 is 25 seconds. So they go down 100 in 25 seconds. That's going to be a slope of -4 meters per second. Okay. And then for this part, they go up 40 in 20 seconds, or that's going to be a slope of 2 meters per second. Okay, so we have our slopes. We got 6 meters per second, 0 meters per second, -4 meters per second, and 2 meters per second. Okay, so let's say we're going to plot this velocity time graph. We're just going to put in those values we found for the slope. So the slope initially was 6 meters per second for the first 10 seconds. Okay, that's going to be a line way up here. Then they sat still for 5 seconds, so that's going to give us velocity right there. Okay. Then for the next 25 seconds, they had a velocity of -4 meters per second. Okay. And then for the last 20 seconds, they had a velocity of 2 meters per second. Okay. All right, so there's our velocity time graph. They started at 6 meters per second, they sat still, they went at negative 4 meters per second, and then they went to 2 meters per second. Okay. And some people like to draw like dashed lines or solid lines down between the points. You'll see that. I don't like to do that. I just like to draw the lines. Okay. But you can put the dashed lines if you want. Okay. But there you go. That's the velocity time graph for that position time graph. Alrighty, so now let's go the other direction. So instead of the position time graph to velocity time graph, let's see how we do the velocity time graphs to position time graphs. So when we're trying to take a velocity time graph to a position time graph, we want to use the area under each part of the graph, okay? And so in this type of graph, it's really easy to see the different parts we're going to take. We're going to take this square right here. We're going to take that square right there, or this rectangle, I should say. This rectangle right here. That one doesn't have any area. And then this one right here. Okay? So we just need to find the area of each one of those different parts. Okay? So I kind of covered up the numbers, I apologize. But if we look here, this block right here has a height of 2 and a width of 3. Well, 2 times 3 is going to give us an area of 6. Okay? This block right here has a height of 3 and a width of 4. 7 minus 3 is 4. So 3 times 4 is going to give us an area of 12. Okay? This block right here has a width of 2 and a height of 1, so that's an area of 2. That second one they're sitting there doesn't have any area. Okay, and then this has a width of 5 and a height of negative 4, and so it has an area of negative 20. Now usually you don't have negative areas in math, right? But for physics we're going to put negatives because we want to understand if it's moving forward or backwards. Okay, so the negative doesn't really mean the area is negative per se, but that the movement is in the negative direction. Okay, so now we have 6, 12, 2, and negative 20. Okay, so now if we try and plot that velocity or that position time graph, we're going to use these numbers to help us out. So the key to drawing these position time graphs is to use the area under each part of the graph to determine where we'll be at each point. Okay, so the first block ended at 3 seconds and had an area of 6. So by the end of those 3 seconds, we should be 6 up on the graph. Okay. Then the next portion of the graph ended at 7 seconds and it had an area of 12. So from that point, we should go 12 up. Okay, so 12 up from 6 will be 18, and at the end of the 7 seconds we should be at 18. Okay. Then there was a block for 2 seconds that had an area of 2, so we'll go up 2 at the end of 9 seconds. That'll put us right here. Then the next area was actually the 0 line, which had no area, right? So we're going to stay where we're at for those 2 seconds. And then the last block ended at 15 seconds and had an area of negative 20. So we're going to go negative 20 down, which will bring us back to 0. Okay. So our position time graph looks something like this. Now my lines aren't perfectly straight, but it will look something like this when all is said and done. Okay. So just use the areas to determine if you're going up or down, okay, from those points, and use the same time interval. Okay. So we now can get the position time graph from the velocity time graph. All right, there's one more thing we need to work with when we're dealing with velocity time graphs, okay, and that's if we have a slope on the time graph. Okay, so we saw this graph before on a previous podcast, okay, where we're speeding up, we're staying at that speed, and then we slow down. Okay, how do we deal with the area of this line right here? Okay, now if you remember from a previous math course, with rectangles, it's just the base times the height, but with a triangle, like this, okay, if we draw a triangle down like that, it's just 1/2 the base times the height. Okay, so we can still do the same thing. We're just going to find 1/2 the base times the height. So in this case, you got a width of 2, or a base of 2, a height of 8. So that would give us 1/2 times 2 times 8. Or in other words, that's going to be an area of 8. So that triangle just has an area of 8, okay? And so you can still treat it the same. You'll know you'd go 8 meters up when you're drawing the position time graph. Okay, this portion right here is just a rectangle. It has a width of, let's see, 10 to 2 is 8. It has a height of 8, so it'd be 64. Okay, this part right here is a triangle and a square, or a rectangle. Has a width of 2 and a height of 4. This has a width of 2 and a height of 4, so this is going to give you, oh, sorry, that should be a 4. So then this has a width of 2 and a height of 4. Okay, so that 4 times 2 is going to give you 8 for that. 4 times 2 times a half is going to give you 4 for this. Okay, and then this block right here has an area of 4 by 4, which is 16. Okay, so when all is said and done, you get 8, 64, 12, and 16. Okay, so you can still use the same thing you did before. Okay, you just have to break it up into more parts when you're using slopes and slants. Okay, but that is your homework. So on your homework, you're going to be taking these graphs, okay, and converting between position time and velocity time graphs. Okay, just remember, if you're going from position time to velocity time, you take the slope. If you're going from velocity time to position time, you take the area. Okay, just be careful to make sure you know which one you're doing. Okay, don't take the area of a position time graph or the slope of a velocity time graph. Okay, all right, but that's it. Let me know if you have any questions, and thank you for watching.